What is Newton's third law? Now, Newton's third law says that for every action, right, okay, let's do this another way. If, right, object A exerts a force, okay, on object B, let's call this FAB, okay, then of course, object B has to exert an equal and opposite force back on A, and let's call this FBA. And so basically, Newton's third law says that FAB equals to negative FBA, right? We call this the action, and we call this the reaction. For every action, there must be an equal and opposite reaction force. And so, how do we recognize action-reaction pairs? Well, there's two conditions that must be fulfilled, okay? It must be the same type of force, okay, and it must always be A on B and B on A. They must act on different objects. They can't act on the same object. And so let us consider now a table, and we have a book on top. That is the weight of the book and the normal contact force. Now, in most situations, the weight and the normal are indeed equal and opposite, but are they action-reaction pairs? Well, they are not, simply because, first of all, they fail both conditions. They are not of the same type, and they both act on the same object, and so they cannot be action-reaction pairs. Now, the question then is, what forms the action-reaction pair with each of these forces? Let's start with the normal. Well, one way to do this is you can always say, well, the normal is the force that the table exerts on the book. And so therefore, the reaction force must be a normal contact force, same type, and then A on B, B on A. So the normal contact force that the book exerts on the table, and there it is, this one, all right? Fn, but this will be book on table. Now, what about the weight? Well, the weight essentially is the force that the earth exerts on the book. And so the reaction force must be here, okay? The gravitational force that the book exerts on the earth. We will talk about this more, of course, when we do gravitational fields. But this is the idea of Newton's third law, action-reaction forces.